Welcome back to the channel. This is the Earth Science Classroom. This video is on atmospheric science, and today this video is talking about temperature inversions. We're going to discuss what an inversion is in the atmosphere and why it's important to understand these natural changes that occur to create a temperature inversion and what's going to happen in the atmosphere once an inversion occurs. This is the Earth Science Classroom. As a basic overview, temperature is the measurement or the value given to the amount of kinetic energy that the air molecules are expressing through collisions. So when energy is absorbed by these air molecules, they're going to become more energized and have more kinetic energy, and collisions increase, therefore releasing energy through each collision, and that energy is recorded as temperature, either in Fahrenheit, Celsius, or Kelvin. Now, Kelvin is more accurate because it really looks at the energy in the molecules and is a little more scientific. However, the more common units is Celsius and Fahrenheit. The term inversion refers to a reverse or opposite occurring within a situation. In this case, it would be the temperature of the atmosphere, and this can be looked at through what's called a temperature profile. So it's the temperature as you change the altitude within the atmosphere. In this case, the lower layer, which is the troposphere, which goes from the surface to around 15 kilometers on average, but it can go higher based on the latitude towards the equatorial regions. So a temperature inversion will be defined as a temporary change to the temperature profile at a certain altitude within the atmosphere. So we're looking at a difference in what to expect at a certain altitude within the atmosphere. A temperature inversion is something that's reversed or opposite to what normally happens in the atmosphere. So what normally happens is you have this radiation that is arriving from the sun through space, through our atmosphere, and a portion of that energy is absorbed by the Earth's surface, whether the ocean or land, and that heats up the surface, and we have conduction of the air mass that's touching the surface, conducting the energy from the surface into the bottom part or surface layer of the atmosphere, the bottom of the troposphere, and this is going to cause convection. So the warmer air mass will rise, and we have adiabatic cooling, which means that a change in pressure will change the temperature, and we have this vertical mixing of the atmosphere where the warm air is rising and it gets to around 15 kilometers above the surface in altitude, where you have the tropopause, is where you'll find the colder air mass, and the colder air mass will sink down to the surface and form a nice convection cycle. The larger ones are the Hadley, the Ferrel, and the polar cells, but you have also smaller cells as well in local areas. But this convection is going to mix vertically the column of air between the surface and the top layer of the troposphere. So what you find in normal latitudes, besides the far extreme high latitudes over the North and South Pole, where you'll find a limited amount of warmer air because of the latitude, what you find is that everywhere else you have a warmer conditions in the atmosphere closer to the surface, and as you go higher in the atmosphere, higher in the troposphere, so increase altitude, there is what's called the environmental lapse rate, which means that there's a certain speed at which temperature will drop or decrease as the altitude increases. So pretty much it gets colder the higher up you go within the troposphere, and that goes up to around -60, minus 60 degrees Celsius, at around 15 to 20 kilometers up at the pores before you start to go into the stratosphere, where there is a change in the lapse rate. But generally in the troposphere, it gets colder the higher you go. Now, what is really cool about a temperature inversion is that reverse or opposite phenomena is that the tropospheric air right by the surface is actually colder, and it gets a little bit warmer as you go up in the troposphere. So increasing altitude gets a little warmer to the point where the warm air mass is above the colder surface air, and then above that warm air, which is called an inversion lapse, you get the regular normal conditions occurring. As it gets colder, the higher you go. But there's that layer of cold air that's stuck right by the surface of the Earth, and then above that would be a smaller section of slightly warmer air, and this is called an inversion layer. And this warmer air is on top of the colder air by the surface, and this is creating the inversion. And what you have is the cold air, because the density it is pushing down. The warmer air mass is generally lighter, and that's going to basically want to rise up. And that situation of cold air mass going down, warm air mass going up, creates a limited or no or zero vertical mixing of the atmosphere. It becomes a temporary stratification, so the bottom layer of the troposphere becomes layered and stratified due to this separation of the cold air by the surface and the warmer air above it. A temperature inversion requires certain atmospheric conditions to occur, and this is a temporary change or reverse to what normally happens in the troposphere under normal conditions, where the warmer air will be at the surface and get colder as you go higher in the troposphere. Now, the reverse or the inversion is going to be where the cold air mass sits by the surface, and this can change in the thickness. It doesn't have to be a large amount of cold air mass or very warm or large change in the temperature between the warm and cold. But when you add in that small difference in temperature, with the colder being towards the surface and the warmer being above it, you can create this inversion. Now, when you add in moisture and different amounts of moisture into this temperature inversion, with the wind being horizontal and not vertical, you can create dew that is left on the vegetation on the surface, and also fog in different quantities and thickness and also duration. But fog can be a temporary atmospheric condition during these inversions. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth science, please check out my channel.